My name is Nurfatihah binti Nasaruddin. My matric number is 073732.
My name is Najibah binti Muhammad Rozali. My matric number is 073806.
My name is Noor Farizan binti Mohamad and my matric number 074347.
Hello, Assalamualaikum. My name is Ilhami binti Ghani. My matric number is 073007.
My name is Khadijah Safiah binti Atip. My matric number is 073739.
My name is Siti Hasyimah binti Sahidi. Matric number 073377.
My name is Mursyidah binti Aria Waruna, alias Mohamad Munzir. Matric number 071891.
Assalamualaikum, I am Farhain, matric number 071958.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Siti Nurfatihah binti Farhain. Nombor matrik 072812, pelajar daripada Ijazah Sarjana Muda Perbagunan Perisian.
Our group represent about X86 and ARM instruction format.
As a maker to prove, the objective for this project are introduction of X86 and ARM instruction format, where we can learn what is meant by X86 and ARM and also their functionally. Next, the structure, design and architecture of X86 and ARM, we can learn the component that contain is both X86 and ARM. For this section, features include the last objective is manage to identify the major profound advantage the advantage user of X86 and ARMs.
Now, I will briefly explain about ARM and X86. So, what is an ARM? ARM is a reduced instruction set computing, or its short form RISC. So, from the word reduce, we can understand that this ARM has a very limited capacity inside it due to its small size. Even though ARM is small, it has other advantages as well, such as cheap and affordable, also less heat release to the environment during the data flow. Meanwhile, for X86 is much bigger than ARM. That's why X86 is known as the Complex Instruction Set Computing, or its short form CISC. Even though this big X86 can process much faster compared to ARM, it has some disadvantages. One of the examples is that this X86 releases more heat to the environment during the data flow. Done with the explanation, now we will proceed for a detailed explanation about the ARM and X86 instruction format.
I represent about the introduction of X86. X86 or X86 was made up of CISC, Complex Instruction Set Computing, that requires numerous cycles to execute. X86, which was designed for personal computers and embedded device, is a microprocessor series that was released after the initial X86 chip. A little bit history about X86. The X86 chip was first introduced in 1978 as a fully 16-bit variant of Intel's 8-bit X80 microprocessor. In order to access more memory than a straightforward 16-bit address could handle, a memory segmentation was utilized as a workaround. The term X86 was developed because several processors that have replaced Intel's X86, including X186, X286, X386, and X486 CPUs, have names that end with 86. By employing the 80, the redundancy is frequently eliminated. Because of that, any 32-bit CPU that have guaranteed compatibility with X86 instruction set architecture was referred as X86 processor.
Let me introduce ARM instruction format. ARM is a reduced instruction set computing RISC architecture. The number of instructions and the number of micro-ops are closely correlated in ARM CPU, which has reasonably atomic instruction. In contrast, CISC provides a much greater number of instructions, many of which carry out several operations such as optimize math and data movement. Better performance is the result, but decoding these intricate instructions uses more power. This indicates that the CPU can execute a finite number of instructions. The effect is that there is only one cycle for each instruction, making them simpler. Besides that, the ARM processor is a special type of computer processor designed for the ARM holding PLC model. However, as it is only partially open, it is difficult to obtain actual documentation for ARM, which has closer to 50. The execution of some of these instructions will need multiple cycles, but some instructions can perform tasks that many RISC instructions cannot. ARM is made to be more heat and energy efficient, as well as smaller. It is therefore ideal for portable electronics like cell phone. It works well for small devices because of its model size. The device's increased battery life is a result of its energy efficiency. For a device that is constantly held, the lower heat is beneficial.
First, I want to talk about the structure, design, and architecture of X86. The X86 architecture is a CISC, which means Complex Instruction Set Computing. It is also a part of instruction set architecture, and it is commonly used in most computers and laptops. It supplies the logical framework to execute any instruction by a processor. By providing procedures, it can manage and utilize the component of hardware of the central processing unit. The services provided by X86, such as software and hardware interrupt handling, memory management, register and input-output management. It contains a CPU where the logic and calculation occur, which had a limited number of storage locations.
The diagram shows the X86 architecture.
Next, the characteristic of X86 is the term is due to the name of the variety of successors to Intel's 8086 processors ending with 86 at the back, such as 80186, 80286, 80386, and 80486. It is a complex instruction set computing architecture that requires numerous cycles to execute. It is capable to run on almost any type of computer such as notebooks, laptops, PCs, and server. The X86 can grasp a maximum number of 4 GB of RAM. It also contains more registers that can store data. The data transmissions consist of only 32 bits via a 32-bit bus in a single go.
Next, for ARM characteristic. First, ARM has high-density code. While using the fewest instructions, the ARM instruction set enables a program to achieve a maximum performance. On any procedure call, the code can switch between the ARM state to the thumb state. Next is register. In RISC machine, it contains massive uniform register file. They have 32-bit instruction set where only 16 can be used at once. Unlike in CISC, each register has their own specific function, but in RISC, each register can contain either data or address. This will improve the system execution process. Third is pipelining. Pipelining is a mechanism used by RISC processor to execute instruction faster by fetching instruction while other instructions are decoded and executed parallelly. Next is ARM structure, design, and architecture. ARM is a reduced instruction set computing RISC. It's a simple yet powerful instruction that can just be complete within a single cycle. ARM is a tiny processor with a fixed length 32-bit instruction. ARM architecture components include boot multiplier, arithmetic logic unit, barrel shifter, control unit, and register file. So, this figure shows the one-off example of the ARM architecture. Lastly, load-store architecture. ARM employs a load-store architecture which only loads and stores instructions that can access memory. It does not support data processing from memory to memory.
I'm going to talk about the advantage of X86 instruction format and disadvantage of X86 and ARM instruction format. So, the advantage of X86 instruction format is X86 processor can perform several activities at the same time from a single instruction and numerous tasks without being affected and many complex calculations. It is also faster than common ARM chip since they have more highly clocked multi-thread and high instruction per cycle. X86 also has a variable line instruction which can be up to 120 bits. X86 it is top in system configurability and expandability, and they offer more powerful performance. Next, the disadvantage of X86 and ARM instruction format. The energy usage of X86 favor high-end processing speed than low power consumption. X86 also pay more attention to performance and processing power, so it needs more power to function, and more power means more heat is released. ARM has fewer instructions, so the developer has to use or create more instructions on their own, and some instructions take more than one cycle to execute. ARM also has limited calculation capacity, so the speed are limited since the ARM needs more instruction and the executable will be longer.
Okay, next I will explain about advantage of ARM. ARM has more safety. ARM has less freedom to install anything than X86, means that lesser risk for the system. Secondly, ARM processor also perform a single instruction at a time and million of instructions per second, so it's faster and quicker response time. Finally, better battery life. ARM consumes less battery since it only performs a single set of instructions. It is ideal for devices that don't connect to the power connection. I am going to explain about X86 and major performance. ARM is a reduced instruction set computing, while X86 is complex instruction set computing. Major performance of X86 is offer far greater power and better performance used by the majority of PC and laptop. Multiple instructions are generated from complex one and execute individually and employs less processing instruction. Each cartridge needs fewer transistors, while major performance can use less semiconductor area and less power, preserving energy for longer battery life. Frequently used in smartphone and other mobile devices, its architecture is capable of managing complex statement execution at a time, and ARM are made to be flexible while handling more difficult jobs.
So for conclusion, technology advances at a rapid pace, whereas computers once required the accuracy of a bus, but now they can be carried everywhere around the world, even in the space. X86 and ARM are both types of microprocessors, but there are certain distinctions to take into account when running tasks on our devices. The majority of people mainly utilize these devices for specific activities such as online education, homework submission, gaming, and international communication. With this, humans could expand their knowledge and also gain the entertainment. Finally, for the time being, X86 and ARM deserve their positions in the evolution of the current technology, where the differences are not necessarily hostile.